All right. So today I'm going to do something a little bit different. I've spent probably most of my sessions here at MPU talking about fragments and authoring. And I've done so many of those, and I still see so much value in those, and I spend a lot of time on them, and I'll reference them at the end of this. But today I'm going to talk about something a little bit different. I'm going to talk about designing SCOM for disasters. And the reason that I bring this up is because I've been working with a lot of new customers lately where we've seen a big uptick in customers scrambling to get off of SCOM 2012 because it's expiring, and they want to migrate over to 2016, 2019, 2022. And what I've noticed when I'm working with them is their disaster recovery plans, their high availability implementations, and certainly their business continuity with multiple data centers were often poorly designed, not working, non-functional. They attempted to do something and SCOM completely failed. They didn't understand why. And there seems to be a lack of clarity on this topic. So because of that, I wanted to just kind of dedicate a session to it. So this will be available for future people, but with the slide deck and the video, as well as the people benefiting from it on this call. So let's first focus on the terminology. High availability, disaster recovery, and business continuity. And there are other words for these things, such as fault tolerance or multi-site failover. But ideally, these are the terms that I'm going to use, and I just want to make sure I can define them. So high availability is the ability of something to operate without failing. Right. So it's where you add redundancy into the system so that it has multiple, the multiple points of failure where one failure doesn't take out the entire system. And then disaster recovery is the method in which we get things back when there is a disaster, when there was an outage created, whether that's, hardware failure. That's what we used to always plan for, was hardware failure. But now, we look more at like natural disasters like hurricanes and typhoons and there's the earthquakes. There's so many different things that could create something like that. And then also cyber attacks. With ransomware being on the rise, Microsoft has certainly seen a large number of our customers get impacted by that. And that's where disaster recovery really has become critical. And then lastly is business continuity. When I first started in SCOM, very few customers cared about business continuity. You really only saw it in the financial sector and then later the insurance sector, which follows a lot of the same rules that the financial sector does. But more and more, I'm seeing this as a requirement in all different kinds of companies where companies are investing in disaster recovery data centers, and they want the ability to have business continuity in case their primary data center goes dark for whatever reason, and to be able to quickly respond to that and where the business is not impacted. So those are the terms, and then we'll kind of go into each one of them. But before we do, I want to just talk about some real basics when it comes to designing SCOM. Every customer that I go into, when we're doing like a side-by-side migration, 2012 to 2019 or SCOM 2022, the first thing I look for is, do you have all your stuff in one place? And I cannot tell you how many customers don't. They are poorly organized. And this is really critical for a lot of reasons. One, it's just a best practice for the reasons that we're going to discuss. But the big thing is, if you ever found yourself in a disaster and you need to rebuild or migrate or fix a problem, having all your stuff in one place on a file share that's highly available across multiple data centers is really critical, so that you're not scrambling to find what you need. I have worked with customers that had to rebuild something And immediately they couldn't find the SCOM media. They couldn't find the SQL media. They couldn't find their license keys. They couldn't find the key that they used to seal management packs with. And so they couldn't update management packs or make any changes. So get organized at the beginning. You want this to be highly available. You want it to include things like your media, your update rollups, any tools you use like MP Viewer, Visual Studio Media, VSAE. You want that all local. You can say, oh, I can just go get it from the web. You may not have access to the web at this time when you absolutely need it, or finding it. Sometimes Microsoft pulls things when they get old and customers still use. And so you need to have a local copy of all of these things. If you've written automation scripts that are critical to your business, like alert updates or forwarding to a connector, you need to have those centrally located. Because if those servers die and are not recoverable for whatever reason, you need a easily recoverable location where all of the critical things exist. It's also where you would save your documentation. You know, your disaster recovery documentation is critical to being able to recover an environment. And so you want to have a place to put all of that. And then also unsealed MP backups, right? I've written a management pack based on other people's previous work that exports all your unsealed MP backups. And to have that on a centrally available file share and not a local SCOM server is critical. So these are the kind of things. And then also, like I gave an example in the image in the lower right for the database engine where I keep multiple versions of management packs over time. Now, I'm probably a little bit over aggressive because I work for Microsoft and I need access to these old MPs, but you always want to keep a couple versions back just in case you upgraded a management pack and then you found some serious critical issue and you needed to go back. When Microsoft updates a management pack, a sealed MP for download, you can no longer get the old one. So if you needed to revert back and you didn't have a downloaded copy, you would not be able to do that. And so for this reason, I strongly advise against using the catalog. A lot of people love to go in the catalog when they build a new environment and they just suck down all the MPs in the catalog into the environment directly into the management group because it's so fast and easy. There's a litany of reasons why that's a worse practice. And this is one of them. You know, you don't get the old version. You don't get a copy of it. Now, technically, you can download it from the catalog onto your file system. But the catalog also does not bring down unsealed MPs, only the sealed version. So you actually are getting an incomplete package when you use the catalog. So again, I'm anti-catalog. I think you should download everything, download the MSIs, save them locally, put them in your highly available file share. So that's my soapbox. I've seen just about every customer I've worked with doesn't do a good job of this. So I had to touch on that. And then when we talk about designs, as I've been working with these customers, what I found is they are often when they migrate from an old 2012 environment to their new environment, they're just however many servers they had, that's what they're doing moving forward. They're just, you know, if I had 10 management servers, I'm doing 10 management servers. And I've gone into multiple customers with drastically over-designed infrastructures, way more memory on their management servers that are necessary for their size, more processors than are necessary, way more management servers than you need. You know, we support 3,000 agents per management server. And my rule of thumb is 2,000 agents per management server in general, so that we can allow for failover. But I can't tell you how many customers I've gone into that will have 8 or 10 or more management servers, and they inherited the environment often. They don't even know why they have that many. So, you know, when you're doing a migration, take a look at your design and make sure it's not over-designed. You know, in all things we do in IT, total cost of ownership should really guide the decision-making process. You want to look at supportability from the vendor, but you also want to look at how much does this cost to run and not waste company resources. So I say don't deploy the shiny new toy. So a lot of customers, man, as soon as we come out with something, they got to have it. They deploy it. They want always on the day we support it. You know, I've often seen that cause customer issues. So there's nothing wrong with being an early adopter, but do it in your test environments, validate it, prove it out. I had a lot of customers when SCOM 2012 shipped and we first started supporting AlwaysOn. They immediately wanted that high availability and deployed AlwaysOn, and they actually their SQL teams weren't really good at supporting AlwaysOn yet. They didn't have that skill set and training necessary. And they were oftentimes the guinea pig and had a lot more downtime. And I'll talk more about that later. So take a look at your design. Make sure it's sized properly. We have a lot of tools out there, and I'll provide some resources at the end to do this. But I mean, our SCOM 2012 sizing helper, I know it's really old. We haven't updated it since 2012, and mostly because the requirements haven't really changed in that amount of time as far as recommended memory, recommended processors, recommended space, things like that. Another thing is don't deploy management servers across slow links. And when I say slow links, people say, oh no, that's a metropolitan area network. It's super fast. What I mean is really high latency links. I have gone into countless customers over the years, and they had 5 data centers, and they would put a management server into each data center because their thought process was, hey, I got a lot of agents in that data center, and I need to be able to monitor those agents. And it seemed like that was the best way to do it. It's actually the worst because management servers, and since SCOM 2012, use resource pools to communicate, and those resource pools of management servers need to be less than 5 milliseconds from each other. And I can tell you 5 milliseconds is practically across the street if we're talking about 2 different buildings. So you really want all your management servers in the same data center with the SQL servers as well. Because when we write to SQL from the management server, when we open a table for editing, sometimes we will take a lock and we will not release that lock until we're done. And any increase in latency increases the amount of locks, and then we create blocking in the database. So it's critical that management servers are very close to their databases as well. Okay, so now we'll move on to the core topic of the discussion, which is high availability. So some examples of high availability might be your SCOM infrastructure, right? What do? We use multiple management servers to create high availability for agents. We do the same thing with gateways. A lot of times, customers will deploy one gateway, and it may just be that they don't care about high availability for such a small number of agents in a DMZ, and that's fine. But if you want high availability, this is cheap, commodity-based high availability. Just deploying 2 management servers lets your resource pools have redundancy. It lets the agents fail over between one and the other. And then the other thing you can do that a lot of customers often overlook is when you deploy gateways and you assign them to a management server, that gateway will not fail over to a secondary management server. It doesn't know about that. You have to configure that in PowerShell yourself. And I've posted some scripts on my blog that help that. But again, this is all cheap, easy to deploy, commodity-based high availability. When we talk about SQL, though, how do we create high availability for SQL? Well, we support 2 methods, AlwaysOn and Windows failover clustering. Windows failover clustering for SQL Server is kind of on its way out. I don't see a lot of customers deploying that anymore because that had a single point of failure in the shared storage that the SQL Server databases existed on. Most customers have adopted and embraced AlwaysOn by now. I still work with some that haven't or are relatively new in that venture. And so you have to kind of look at what does my company support? What do we have good resources for maintaining and a proven track record of maintaining that high availability? And that's the technology I would choose. But the default is going to be AlwaysOn. So I talked about cheap HA, right? Multiple managed servers, gateways, and resource pools, kind of built in out of the box stuff. And then I'll switch over to expensive high availability. And that's where we get into always on and clustering. And so the reason it's expensive is because it increases the server counts. It requires maybe additional SAN storage, or it doubles the amount of storage I need in an always on scenario. So there are lots of reasons why that, or it may require enterprise edition of SQL and move us up from standard edition, which is included in system center licensing. Not the standard edition's included, not the enterprise. And so that's where those choices really have an impact. So one of the first things I do when I'm talking to a customer that wants HA is I ask them, why do you think you need HA? And the question I ask is, are you allowed a short outage for monthly patching of the SCOM infrastructure? And therefore you'll have an outage of SCOM for a period of time during patch management. If you're allowed a temporary outage of SCOM as a monitoring infrastructure service for monthly patching, I argue that you do not need HA. I have worked with customers. I have one right now that had deployed always on, and they had a lot of challenges with it. And the biggest reason they deployed it is because it was the shiny new toy. And some consultant told them that they needed it. This is what everyone was moving to. And so they did it. And so they went enterprise edition, multiple servers, and they never really leveraged that technology. And they also had a lot of challenges where their SQL team wasn't really that good at supporting it. It actually can create increased downtime. And I'll talk about that a little bit more in detail. So the first thing I always talk about with customers when it comes to HA is, are you sure that you need this technology? Because there's a lot of things we can get out of the box, but from the SQL perspective, that's where the expense goes up and the complexity goes up. And so I've actually taken customers who were using always on, and then when we did a migration, we migrated away from always on. So I'm not an anti-fan of always on by any means. But I think that you need to deploy the technologies that meet your service level agreements and your business requirements. So let's say, okay, I've looked at all your reasons, Kevin, and I'm choosing always on for SQL high availability. What are my options, right? So the most common choice is Enterprise Edition. Because there's no restrictions, you can have multiple availability groups, multiple databases per availability group, and multiple replicas in an availability group. And so it's the easiest to deploy. If you want advanced scenarios, it's a no-brainer. You have to choose it. But I do want to call out Standard Edition does support something called basic availability groups, but the restriction is one database per AG. And so that's, at first everyone said, oh, I can't use it then because I got the OpsDB, I got the data warehouse, this isn't going to work. But, however, we do support multiple AGs in a single instance. And so you could have the OpsDB in one availability group and the data warehouse in another availability group. You're also limited to only 2 replicas. So this solution is really most designed for like local HA. You wouldn't be able to have a third replica in a disaster recovery data center. And so it's very limited for a reason, because it comes with Standard Edition, which is included in System Center licensing. So if you want HA and you want to do it on the cheap, this is something that you can investigate. Otherwise, most companies they only support always on with Enterprise Edition. So what choices would we make? Well, if you're doing local HA, you're going to choose synchronous replication and automated failover. That's the closest you can get to kind of clustering. It's just critical if you're using synchronous replication. What that means is when SCOM writes to the primary database, the write isn't completed until it's been verified on the secondary database. And so if you had any latency between the 2 servers, that would basically bring SCOM to its knees. So you must have incredibly low latency. You want them in the same data center on the same subnet. for local HA, if at all possible. Or, if you want to separate subnets because you're also using network HA as part of your design, that's fine. It just needs to be very low latency. Behind the scenes, we're actually using Microsoft clustering because what we do is we fail over the listener name from one node to another node in AlwaysOn. But again, most people, the SQL team sets this up. They don't really need to know all that. They just need to know what's my listener name, because that's what I'm going to install SCOM to. So what are the downsides to AlwaysOn? I kind of mentioned, I've had a lot of experience with customers with AlwaysOn, and I know Microsoft would not really like me saying this that much, but I used to joke about but this is back in 2012 when AlwaysOn first came out. I used to call it Always Down. And the reason I called it that is because it was brand new, and customers that implemented it without proper training, administration, monitoring of SQL, what would happen is transaction log backups would fail. They wouldn't respond quickly enough. The transaction logs would fill the volume, and then the environment would go down. And so it actually potentially increased downtime. And the reason is when you use any type of SQL replication, you must switch from simple recovery model in SQL to full recovery. And what that means is you have to back up your transaction logs. It's the only way to checkpoint them. And you also need to consider tripling the disk size of your logs. So in SCOM, I'm sure most of you know, like we recommend for the OpsDB, like if your database is 100 gig, then we want a 50 gig log, right? And so it's very easy to plan. Okay, well then I'm going to deploy 120 gig volume for the databases, and then I'll deploy a 60 gig volume for the logs, and I'll never be full, right? I have a little bit of room to grow. If you choose AlwaysOn and you have to move to full recovery model, your transaction log volume size needs to be much, much larger, because if it ever filled, that 50 gig, which is half the size, it needs to auto grow. And so you need volume size for that. And so when I do it, my rule of thumb is 3 to 4 times what I would choose if I was doing simple recovery and I wasn't using AlwaysOn. So something to think about. And then some downsides are also the expense, right? If we're using AlwaysOn, we're usually picking Enterprise Edition. It's a very different cost structure. And then also AlwaysOn doubles my compute and storage. So I have multiple machines that now double the amount of machines. And I'll show some examples of that coming up. All right. Next, I'll go to disaster recovery. So we covered high availability. Now let's talk about disaster recovery. So this is, again, the method of regaining access to the functionality or the service after a disaster occurs. And the most important, this is simple, right? It doesn't matter if you're using HA, if you're using multi-site failover, everybody needs a disaster recovery plan. No matter what your design or your deployment or how much fault tolerance and redundancy you've built into a system, you have to have a DR plan. That starts with a document. It's one of the first questions we ask when we do a health evaluation of customers. When we do the interview process, we say, show me your disaster recovery documentation. A lot of people just never actually take the time to develop it, and it's really important. This is where you would document things like, what accounts am I using, right? What are how do I get their passwords? What's the process of restoring? Where's the media, that highly available file share, right? And then it's also important to test your ability to recover. I had a customer who lost their data warehouse database due to some underlying storage corruption, and they went to go restore it, and the backups were no good. They had been backing up a corrupt database for a long time, and they no longer had the retention. So you need to test your ability just from a functional perspective. And then obviously you need to make sure that your backup plan includes enough retention that if you were backing up something bad, then you can go back far enough and get something good from it. And so what do we back up, right? We back up SQL database. That's the most critical thing. And that includes the ops DB and the data warehouse. If you're going to restore one, you must restore both from the same time period backup. You can't just restore your ops DB or just restore your data warehouse, because there's a synchronization between those two. And so you really want, it's impossible to have a backup taken at the exact instant of both, unless you shut down SCOM and nobody was writing to either database and then you did a backup of both, which is unrealistic. So we just advise, hey, if you're going to restore one, restore both. If that's all you had was your SQL database backup, you actually can recover the entire environment. You can build all new management groups. We have a recover switch that it causes you to have to enter in passwords for the run as accounts in that situation. But if that's all you had left, that's the most important thing. The second thing to back up are VM snapshots. And the reason we want to do that is that really speeds up the recovery of management servers. Unsealed MP backups. I think most customers I run into are doing this. That helps you. I had a customer just the other day accidentally deleted their secure reference management pack, and we all just were like, oh no. And luckily we had unsealed MP backups. We just very quickly re-imported it, and we didn't lose all of our run as account associations. And then again, that file share. Really important, because that file share is going to be your single place to go if you're going to do a rebuild of an infrastructure. Okay, so next up is business continuity. And like I said, this is something that not a lot of customers were doing early on, but I see it more and more. This is where I have multiple data centers. Maybe I have one data center that's literally designated as the DR data center. And I kind of frame it like this. If a plane crashed in to your primary data center, what happens next? How do you run your business? And with asking that question, they say, oh, well, we'd all go to the DR data center and execute everything. And so we say, okay, how long are you allowed to have before SCOM is back up and functional? And so some customers are like, if a plane hits our primary data center, we got a lot bigger problems than SCOM, right? And other customers are like, nope, we are required by the business to have another system ready to go, and we have 4 hours, 8 hours, 48 hours of outage time allowed before we have to restore service. And so based on that restoration of service limit is going to decide, what you pick here. So there's 3 methods that I primarily think about and run into when we talk about business continuity. And that is, I have 2 data centers. I just do 2 management groups, multi-home all the agents, and I have 2 identical environments up and running. If one fails in the primary data center, I just immediately switch over to the secondary. The other one is what I call the stretched management group, and this is very popular, and I'm not sure why. But this is where I have 2 data centers, 1 management group, and I kind of spread them out. Spread out the resources, and I'll go into more detail here in a minute. And then probably my favorite is VM and storage replication, where I have a single management group and I just replicate everything to the DR data center. So let's talk about each. So here's multiple management groups. The nice thing about multiple management groups is it's easy to support. Everybody understands multiple management groups. You don't have to have a lot of fancy technology or anything proprietary. But one of the downsides is when you multi-home everything, your agent load potentially increases. The amount of memory and CPU that an agent consumes to do its job when you're multi-homed with everything is potentially harmful. And so it's something that you'll have to keep a closer eye on. Also, you're more likely to breach thresholds on agents like memory or handle count leaks. And so you'll need to look at that. And then lastly, from time to time, we have issues where our management packs don't support the same 2 workflows from 2 management groups running at exactly the same time. And so you have to go mitigate that by putting in timing overrides, or we have to fix our management pack. We just had an issue with the SQL management pack caused by that was related to this. So And then configuration drift is a problem. You know, if you make a change in one environment, did you make it in the other? How do you keep your management packs in sync? I've seen customers automate it with scripts every night. It's just, you have to come up with a plan for these things. The other issue is third-party costs. So if you paid for a connector to go to ServiceNow, let's say, a lot of times those third parties license you per management group. And so if you do 2 management groups, you've got double the licensing costs. So it's something to look at and consider. The nice thing, a big upside, is it has the lowest potential for downtime because it's just 2 totally independent groups. And then another downside is it's the most expensive solution because it literally is double the resources, twice the managed servers, twice the SQL servers, twice the gateways. Whether you do HA or not is irrelevant in this. It's going to be double the cost of whatever you do between the 2 management groups. So the next one is stretched management groups. And so this is where I do a single management group. I do always on replicas. So in data center A over here, I have maybe local always on for local HA, and then I have a replica of those databases, and I can have redundant replicas or I can just have standalone replicas at that case, at that point. But I'm basically replicating my SQL Server to data center B, and I have the ability to fail over that listener to that site. And then I put management servers in both locations. So this works. Lots of customers have implemented this, but I've also seen it fail a lot. And the biggest challenges are latency that I talked about, right? Small environments, the latency between these 2 data centers has to be less than 20 milliseconds. So if you've got a data center in Los Angeles and another one in New York, this is not going to work. Your latency, just the speed of light can't travel that fast across that many miles. And so the latency must be considered in this scenario. And so for large environments, we want to see it no more than 5 to 10 milliseconds. And then also your resource pools. What you'll do, especially if you have high latency, is you'll limit your resource pools to data center A. You'll pull the management servers in B out of those pools. And then if you had a site failover, you would then go have to manually or script the addition of those management servers in data center B back into the pools. So it's a complex recovery because it requires a lot of scripting or manual intervention and changes potentially. There's no support for reporting in this scenario. And so that's something that you have to keep in mind. And disaster recovery is scalable. You know, this can be high, local HA or reduced footprint in the failover data center. So if your data center B only needs to run the business for a short amount of time and you don't need as much HA, you can reduce some costs here over multiple management groups. But I do kind of note this is the most common to fail because I've seen customers design and deploy this and have all kind of problems not realizing latency was driving this. And I also call it the medium cost option. And that's because it's less than multiple management groups. Okay, so now we'll talk about my favorite solution, which is VM and storage replication. So what this is where I have a single management group and I'm literally taking the same machines and booting them up into a disaster recovery data center. So whatever I have in data center A, I have, maybe VMware or Hyper-V VM replication to another one. Maybe I have block level storage replication to move the SQL data over. This could be, or I'm using AlwaysOn and using replicas with AlwaysOn. So it can be a hybrid approach. But this, I've seen this work in a lot of customers that have this capability. The benefits are you don't have to do anything. When you do a failover, those management servers that were in data center A are literally now running in data center B. So they will get a new IP address. You'll have to address that. You'll need DNS to have a short time to live so that everybody picks up whatever their new IP address is when you're doing this failover. But the agents just communicate, talk to the management servers talk to the local SQL server because they're using the same listener name in data center B as they were in data center A. So I really like this. The only problem is not all customers have technology that allows VM replication or storage replication to be able to implement this, but it's certainly the one that I go to first and foremost. All right, so let's just talk about a couple quick design examples. Um, Here's, company Contoso One. They have less than 1,000 agents. They don't do Unix and Linux. They're allowed monthly outages for patching, so they don't need HA for SQL, but they deploy 2 management servers because that's our standard. So this is the simplest design. It's probably also one of the most common designs out there, and this supports up to 1,000 agents. So if I add a bunch of Linux systems, that at that point I'll say, hey, let's go ahead and deploy 2 more management servers and have a dedicated pool of 2 or more management servers for the Linux system. And obviously with this design, as you scale up in agent count, you would just add more management servers. So the next one is, hey, I've got 3,000 agents. How does that look different? Well, all you do to scale up to 3,000 agents is split your OpsDB on a SQL server and your data warehouse on a SQL server. I still have HA with my management servers. I just don't have HA on SQL because, again, I'm allowed to do monthly patching and take SCOM down for a period of time. Contoso 4 is the exact same as the previous one. We're just adding 2 management servers for Linux. And Contoso 5, now we say I must have local HA, right? And so this is the 3,000 agent. I've got some Linux systems, but I need HA. That's fine. I'm just going to deploy AlwaysOn for my OpsDB and AlwaysOn for my data warehouse. And again, I can use standard edition or enterprise edition in this case, because these could be basic availability groups, or they could be enterprise availability groups. Excuse me. So now we're getting into the big time, right? I'm entering in that I need business continuity. And so this is where that same design that I just had, but now I'm going to either use multiple management groups, a stretched management group, or VM and storage replication as my solution. But ultimately, it'll be the same technologies. This would be probably the most complex that we would see. All right, so let's review. Based on everything that we talked about from a high availability, disaster recovery, and business continuity, the first thing, set up your highly available file share, right? So you are prepared. Don't over design. Think about total cost of ownership and supportability of your environment. Don't make things too complex. Keep all your management servers in the same data center with the SQL servers. I just can't stress that enough. Another thing I'm starting to see is customers are moving to Azure, and they want to put, management servers in Azure, but keep their database on-prem. Not going to work. The latency will be too high. Even with ExpressRoute, I've never seen that be successful. So if you're going to move a SCOM environment into Azure, that's great. We've been doing that a lot lately. You just need to deploy your SQL servers on VMs in Azure and your management servers on VMs in Azure. Don't deploy HA if it's not required by your business and your service level agreements. I can't stress that enough. Just because there's a shiny toy doesn't mean you should deploy it. And remember that business continuity and HA, they come with a price tag in both compute, storage, and licensing. But DR, on the other hand, that applies to everyone. It's critical to everyone. Everyone should have a DR plan. And then if you're going to go with business continuity across multiple data centers, look at all 3 designs and do your due diligence and figure out, hey, for my capabilities, for my company's capabilities and my service level agreements to restore the service, what makes the most sense, right? And then always remember, network latency is critical in any part of the design process. So it's one of the first things you should look at. So resources, obviously, you know, we'll make this deck available. I always kind of point people to my blog. I usually have information up there. I'll probably have a post with this video on it. The planning guide that we publish on our docs is actually really good. It talks about all these things that I talked about. It's gathering your requirements and then mapping those requirements into a design and talking about all the different options. It's not as exhaustive as what we just went through, but it's really good, and I do recommend you go through it. I mentioned the SCOM sizing helper for proper sizing. That's still available. I've included a link there. And then also, if you're going to deploy AlwaysOn, make sure you're deploying it in best practices. So SCOM doesn't really have any requirements for AlwaysOn other than we don't support like multi-site failover, a very specific type of failover where the connect string doesn't have to change. There's only one very specific aspect of AlwaysOn that we don't support yet. But I think that's on a roadmap, or it might even be in 2022. I'm not sure. But for the most part, hey, we just want you to follow whatever SQL best practices are for AlwaysOn. That's what we want you to deploy. And so I've included a link to that as well. And then lastly, I just wanted to touch on, you know, I know that this is Select MPU, and there's always a lot of talk about fragments, and you've seen some examples of those today. So I just wanted to, you know, let everyone know I'm still working on these all the time. I still take customer feedback. I'm always updating these, so I'm including the links to those. You can use Visual Studio, or you can use Select MP Author Pro or Select Studio. Both work just fine. Select makes it a lot easier to use. So understand that. And then, you know, how many are there's 112 fragments that are been published today. When I did my first demo, I went back and checked today. When I did my first demo of fragments, I had 17 fragments. So obviously, this is an area where, you know, I've continued to support. Select obviously is adopted and continue to support this. And for the customers that I have converted to using fragments and Visual Studio or Select, they are wildly successful at authoring, and they often don't even need my support to author things anymore once they get really good at this. So if you haven't played with them, if you haven't tested them, the link is here. I do recommend you go take a look, because it will change the way you author things and help you focus on monitoring things for the business and not just out of the box management packs. And with that, I'm complete, and I think we're going to move into Q&A.